c, the wave speed. And that is equal to u is E RMS B RMS divided by mu 0 c. In other words, this is I. If you divide that by c, you get mu 0 c on the denominator. So that is an expression for the radiation pressure. You can also write it as E max squared divided by 2 mu 0 c squared. Now, how did that come about? Can you picture that? Well, E equal to CB, so B equal to E over C, and that is where the E squared comes in, and the C goes to become C squared. Is that right? Replace this B by E over C, and you get that equation. So the radiation pressure is E max squared divided by 2 mu 0 c squared. And that can also be written as B max squared over 2 mu 0. How? By replacing E equal to CB. Alright, let's do a small problem. A 50-watt electric light bulb emits spherical electromagnetic waves in all directions. Find the intensity of the waves. Well, this is where the original definition of intensity is going to help. What is intensity definition? It is the power crossing unit area at that point. That's how we're going to calculate that intensity. The radiation pressure and the electric and magnetic fields at distances 3 meters from the bulb. Well, in fact, I'm standing about 3 meters from the bulb, and this problem is very much applicable in my case. What is the radiation pressure on my face? What are the values of electric and magnetic fields where I'm standing? Well, the intensity I at a point is a measure of the power per unit area at that point. Is that right? So, I equal to 50 watt divided by 4 pi r squared. In fact, that's the bulb about 3 meters from there. That's the distance r. And you can see if I construct a sphere of radius r, the total power that is going out of that sphere will be, that's the total power. If you divide by 4 pi r squared, which is the area of that sphere, that will give you the power per unit area. I hope you understand that. If I have the bulb, lighted bulb here, if you take a surface of radius r around it, the area of that surface will be 4 pi r squared. So if you want to find the intensity at any point, divide the total power, which is the 50 watt given to us, by the total area, which is 4 pi r squared. So intensity I is power divided by the area, and that will be 0.442 watt per meter squared. Once you know the intensity, we can find the radiation pressure. What's the definition of radiation pressure? Radiation pressure is intensity divided by C. So P sub R is I divided by C, and we know those values. That gives you 1.47 times 10 to the negative 9 Pascal is the radiation power. Well, we now need to find the electric and magnetic fields where R equal to 3 meters. And for that we go and select this equation. We had obtained several equations for the radiation pressure in terms of electric field and in terms of magnetic field. So we are now going to use the equation in terms of electric field. PR is E0 squared divided by 2 mu 0 c squared. And we know all these values. Therefore, E max, well, E max is the same as E0. But E0 squared is 2 PR mu 0 c squared. Therefore, E max is the square root of that quantity. And use all those values, we just calculated the radiation pressure. We know mu0 and we have C squared. That gives you E max. The maximum electric field is 18.2 volts per meter. Now in the same way you can calculate the magnetic field. I think I'm going to leave that for you and go to another problem. The amplitude of an electromagnetic wave is E max equal to 140 volts per meter. Find E RMS, B RMS, the intensity I, and the radiation pressure P sub R. Well, they're all direct applications of the formula we have. E RMS is E max divided by square root of 2, and we have E max. Therefore, the RMS value of that voltage is, of that field is 99 volts per meter. Now, B RMS is E RMS divided by C. Is that right? Yes, because E equal to CB. So since we have E RMS, B RMS can be calculated as 0.33 micro Tesla. Now, radiation pressure, the intensity is E RMS, B RMS divided by mu0, and we have both these values, and that gives you the intensity as 26 watt per square meter. And what else do we need? The radiation pressure. Well, we have the radiation pressure P sub R equal to I over C. We have I and we know C. That is 8.7 times 10 to the negative 8 Pascal. Well, simple problems, but you must be able to recall all these equations. Well, and that is the end of our discussion on electromagnetism. And I think in this unit I'm going to include a lesson on light, because it's very